read their.
This meeting is being recorded.
I would like to read their biography so that I can introduce them to you. However, to do that, I need to know, are you going to be speaking first, Jay?
I'll go first, yeah. And then Andrew will.
Okay, sounds good. So then let me do that. So Jay Trimble is the mission system manager for the VIPER Lunar Rover Mission at NASA Ames Research Center in Silicon Valley, California. Prior to this, Jay founded and led the user-centered technology group, which developed open mission control technologies, OpenMCT, the MERBoard Touchscreen for Mars Rover Operations, and Planetary Data System user technologies. At UC Berkeley, Jay was the integration and test manager for the high-energy solar spectroscopy imager. At the Jet Propulsion Laboratory, Jay was lead operation director for Space Radar Lab, which flew 2 successful missions on the Space Shuttle Endeavour. He was a member of the Science Operations Support Team for the Voyager Spacecraft encounter with Neptune. At Johnson Space Center, Jay was a Space Shuttle mission controller in the Payloads discipline. Jay has a bachelor's degree in geology from UC Berkeley and a master's degree in computer science from USC. So welcome to Izmir, Jay, and we've been very eager to listen to you, and many people today have said OpenMCT, they will talk about it later. So finally, the time comes for OpenMCT, and I am very interested in this product, and of course in everything you and Andrew will tell us. So without further ado, let's welcome Mr. Trimble. Thank you.
All right, well, I'm glad to see there's so much interest out there in OpenMCT because it is kind of a labor of love. Let's see what we can do here to share the screen. Now you guys are probably seeing, just give me a second here.
I see myself.
All right, hang on, we'll fix that. How's that?
Yeah, that's better. Thank you.
Okay.
you scared me there for a moment. Who's that guy? Okay, thank you.
Oh my God. Okay, so Andrew and I are from Ames Research Center, which is part of NASA. I think most people, when they think of NASA, probably think of Houston, right? Mission control, astronauts, or Cape Canaveral, our launch site. But we do have a center in Silicon Valley, California, and that's us. So I'm going to give an overview here and talk a little bit about why we built OpenMCT and what the capability is, and why we went open source, because the original MCT was not open. And had we stayed in that direction, probably nobody would ever have heard of it. And then Andrew's going to get more into the technology, give a demo, and maybe even do a little snippet of code. So I want to, as backdrop, just think about the evolution of mission control. And I want to ask the question, you know, how have we changed, right? How far have we come? And on the left in this picture, you'll see the 1960s. You know, this was probably before most of us, right? Some of us, like I was born, but I, you know, barely when this stuff was going on.
Yeah.
But the Mercury Mission Control Center was largely mechanical. And that was at Cape Canaveral, Florida. And then Apollo Mission Control, which is very famous, probably most people have seen that, was mainframe based, and that was in Houston. And then client server for the Space Shuttle and ISS. And I just want to think a little bit about the role of technology, which has clearly changed versus have we changed fundamentally the way we operate? Because it all has to do with why we built OpenMCT, right? There's so many platforms out there. There's so many ways you could look at telemetry, so many applications. And there are reasons why we decided to build a new one. Kind of summarized here, right? We wanted something web-based. We wanted it to be open source. We wanted a modern user interface. We didn't want different applications. We wanted a usable, unified environment. And then we wanted something that was easily customizable by the user, that did not require programming, and something that worked on desktop and mobile devices. And I also want to note, we'll leave time for questions and answers, because if there is interest in OpenMCT out there, we'd like to understand more about that. So, we started this out in the days of closed systems. Open source was pretty new. Obviously, now it's OpenMCT. Traditionally, ground systems have been proprietary. And the result of that is we're constantly duplicating effort. Everybody's recreating the same thing. And we wanted something very different where we could build on each other's work. We want to make the ground system work that we do available to anybody who wants to use it. And our hope is that other people will then build on that and create a global community so that we can all build on this stuff, right? I mean, there's so many things to do in space. There's so much work to do. There's no reason for us to be recreating the same thing over and over. So just a little bit of background here, again, on how we got here. And this was mission control in the early days of the space shuttle. And what I want to point out is the relative inflexibility. And note, this system was absolutely state-of-the-art. When this was built for Apollo, there was nothing like it. But I want you to imagine, look at those displays and imagine using something like that now, right? They were monochrome, very simple, no flexibility in the layout, and we had to get these specifications in for what a display would look like months ahead of time, so that by the time we started training for a mission, we really couldn't change anything. And that inflexibility is really what led to the OpenMCT vision that you're seeing finally manifested today. And also note the plastic overlay status lights. I mean, it was such a different world, right? And it all worked. It worked beautifully. It just required a lot more labor. It was not particularly flexible. And as I already stated, right, we started out, it was mainframes, very centralized, then a little bit more distributed with client server. And now with virtualization and applications and components, we have a degree of customization we didn't have before. I do want to point out the issue that we see with applications, which is, applications are their own encapsulated worlds. You have heterogeneous environments with walls around them that essentially turn users into integrators trying to bridge those walls. What we wanted to do was integrate all that so a user is not looking at things like what you see here that look so dramatically different, that they have one way to interact with their stuff, but that way has to be very flexible in order for it to work, and that all their data is available in one space. So let's go a little bit into OpenMCT. And again, Andrew will demo this for you live. I'm just going to introduce the basic capability and again, why we did it. So on the left, you'll see a data explorer, right? And that looks like the types of things you might be familiar with in your Mac Finder or in Windows Explorer or on whatever version of Linux you may use. Because when you're using an environment like that, right, you think of all your stuff in one place, right? But that has not traditionally been the way of applications. And even when you're using applications on your personal computer, those environments may be very isolated, right? Specific data type associated with a specific application. And that workflow works in your personal computing life. But in our mission control world, where you have all these different disciplines interacting in a mission control center, you want to be able to see and integrate that data. So having that all available in one space like we have here is a big step forward for us. And also integrating the real-time data with the historical data, another big step forward. And I'm sure Andrew will say a few words about that when he shows you the demo. And about this display, what I really want to point out here is the different data types, the different domains, and also that all of this is put together through end user composition without a line of code having to be written by the end user. And you see a recreation of the old status lights, right, on the upper left, power, thermal, NSS. Those were those simple plastic overlays that were binary back in the day. Now they can have complex logic behind them. And again, the user, the mission controller, can do that without writing a line of code. And of course, you see plots and telemetry and imagery, and almost any data type you can think of is probably possible here. I'm not going to say a lot about composition because Andrew, I believe, is going to show you, but I do just want to point out that, you know, you have a create button, which you see on the left, right? You can create these different component types, and then you can put them together on a canvas. And again, you know, if you're used to this from modern software, you may be thinking that that's what you'd expect, but this has not previously been available in an integrated way on any of the mission software we've had. And here's just another example of some of the data types that we have. You see procedures there. You see an activity timeline, a 3D rover, and clocks and timers. Okay, and again, I'm hoping that folks have questions about this and you're saving those up and that you'll ask us at the end. View it as you want it. The point here is that you have data, right? And different mission disciplines want to view things in different ways. This is a very simple example here from one of our older displays showing different plot types overlaid and stacked. But again, the point is, once you've put this display together, you then have different virtual eyeglasses. You have different ways of looking at this data. And a scientist may want to see their data in a very different way from an engineer. And if we don't give them that capability, they will create it themselves, sometimes creating a disconnect, right, where we're jumping across different systems. And again, that's something we wanted to avoid. Also wanted to point out that this data works on mobile devices. And on a space mission, when you're on a mission control shift, which is typically an 8-hour shift plus a 1-hour handover, you know, there's 16 hours a day where you're not there, and you still want access to some of that data. That could be for decision support for the person on console, right? Somebody on console may want to talk to somebody who's not there, have them look at data. You may just want to check in on your spacecraft, but it creates a continuous connection that, again, we didn't have that capability even recently. Okay, I'm going to say a few words about open source, and then I'm going to turn this over to Andrew. So obviously you all know this is open source. Presumably you've seen the OpenMCT website if you're interested in OpenMCT. What I want to point out here is that we did a website with information and with documentation and with a demo. It's a slightly dated demo, but it's still a demo. And then, of course, we have what you'd expect, which is a GitHub site with code. Just throwing something over the fence in open source, right? Just putting it out there without support, I think is very problematic. And we wanted to give users and developers enough support so that they could effectively use the product. And I think that strategy has paid off. So it seems obvious now how open source enables collaboration, but when we went in this direction, it was still fairly new. When we were proprietary, you know, really, we were the only users of our software. Now that it's open source, of course, we have this large community really across the globe, which is very exciting. But one of the reasons for that is, you know, you eliminate the ownership issue, right? Anybody can take this, they can do anything they want with it. They don't have to ask our permission, but many folks do choose to interact with us either through making a contribution or just simply asking questions. And of course, we really like feedback. One of the great benefits of open source is it broadens the community of users, and each one of those users, by telling us what they want, by telling us their experience, they make it better. They give us a better product. So more eyes on the software, more users. And I think it's really important to note that before that, the community of users was the mission community, right? And of course, any users drive you to be better, but the mission community internal is a pretty small community, it numbered in the hundreds. And through open source, you know, we've got eyes, users, and feedback that we just never could get if we stayed internal only. Okay, I just wanted to throw out a couple of quick examples from the community. And a lot of times we just find this stuff by Googling our own software. Unless somebody reaches out to us, we don't have any way knowing who's using us for what. So I just want to take this moment to say, let us know what you're doing with the software. Tell us how you're using it. Tell us what works. Tell us what doesn't. Tell us what you'd love to see that's not there. Or, build a piece of it yourself, put it into the community. And then I don't know how many folks are familiar with Kerbal Space Program, but we did have some folks at some point writing a plugin for Kerbal. Okay, I'm showing one example of a contribution from the community, and I want to note there's a range of examples of how the community can contribute. It could be as simple as catching an error in documentation, using the documentation and giving feedback, or it could be a tangible piece of code, as we see here. So this was the capability to export a plot as an image, and that was something we had put out in our issue tracker, and somebody from the community built that. Great example of community involvement. Our process is, it's a little old-fashioned. You still have to sign a contributing license agreement, and I believe that is still done on paper. But if you go to the website, you can see how to do that. And we do have a number of contributors across the world. And then I've already mentioned this, right? We've got the active web presence, one with the information site, and then one with the GitHub site. So when we started OpenMCT, our focus was really on the end users, the mission controllers. And of course, when we went open source, it became very important to provide a code base that people wanted to interact with, right? That was clean, that was something with fun, that was interesting to develop for, that had an API that made sense. And then, with tutorials out there, so people know how to use this. And what I'm really saying here is that for an open source product like this, developers are also a key part of the user community and something that we need to consider. Okay, so, where are we headed in terms of open source? So, we've certainly proven that open source works for collaboration and adoption. In terms of building a unified community of contributors, or at least a connected community of contributors, we have great contributions, and we have found also that the steps that users need to take to make a contribution, right, at least if they are NASA users, right, there are still legal impediments, legal barriers, and a lot of people build capabilities, but they keep them to themselves. So that's something going forward that I'd like to take a look at, is how to create a community of active contributors that are taking what they build and making it not just for themselves, but for the broader community. And what I'm finding is people really want to make their contributions available, but that their organizations, in some cases, don't empower and enable that. So for an individual, that's no problem. But for somebody within an organization, they need to get permission, and there are sometimes legal issues. So overall, I still say open source is a great vehicle for adoption, for collaboration, for building community, and hopefully going forward, it will become a vehicle for advancing the technology and moving us forward. And with that, I am going to hand it over to Andrew.
Well, this is great, fantastic, Jay. And before the next speaker, Andrew, speaks, I would like to introduce him, of course, but I would like to thank you